Welcome all of you. Today I am going to start the module 2, that is a wiring system. Before starting the actual syllabus, actual chapter, let's look up the syllabus. So this actual module 2 is divided three parts: wiring 1, wiring 2, and the internal wiring systems. So in wiring system, we need to study the introduction part, distribution of energy in a building. That is from the service mains part. From the actual service mains, the whatever amount of power that we are getting into our home, from that point actual distribution starts in our home. So that's just distribution of energy in a building. The PVC casing caping, that is different type of casing caping methods are there. In that we will study about PVC and some conduit wiring, and what are some major disabilities of wiring there, and what are those disabilities, we can study that. The types of cables used in our internal wiring system, that is there are different types of cables are there. We need to study that what are the different types of what is meant by cable, what is meant by wire, that also we can study in that. And what are the based on the ratings, how we need to go for cable selection, that also we can study. And the multi-standard cables, that is different types of cables. In that multi-stand cables comes in the voltage grading, the specification of cables, and this is the first part. So we will continue from this, and late after completion of this part we shall see about wiring part 2 and internal wiring. Okay, this is actual distribution wiring system. How much how much not, it's actual wiring system that our home and typical housing wiring system. Here the network wires connecting various accessories for distribution of electrical energy from the main supplier meter board to the different electrical energy consuming devices. That is different electrical consuming devices means our home appliances. That is from actual supplier meter to the different home appliances meter. This is the actual distribution diagram. And connecting such as lamps, fans, and other domestic appliances through the controlling and safety devices. This is known as wiring system. That is what is meant by wiring system: a network of wires connecting various accessories for distribution of electrical energy from supply meter to the our daily home appliances like lamps, switches, and fans, and other home appliances of a domestic appliances through a controlling and safety devices. Controlling means switches, safety devices means fuse. So through the fuses and through the what you can say fuses, switches, actual supply will be get from the service mains to the our home appliances. This is the whole system is called wiring system. Here, see here the service mains. This is a actual service mains will be have three-phase four-wire system or single-phase two-wire system. For our home appliances, we need single-phase two-wire system. Single-phase two-wire system consists of one phase and one neutral, and one earthing will be common for all the devices. So from this phase, one thing you people need to remember that the phase or positive wire or the which should be always connected to the switches, and the neutral, this neutral link should be always connected to the appliances. That is for what we can say for lamps or for fans, like that the neutral should be looped through the lamps, switches, and other, sorry, not switches, lamps, fans, and other devices, but phase should be always connected to through the what we can say switch. This is how the first point you people need to remember in wiring system. So in this typical wiring system, distribution wiring system, this thing is the meter board. That is from actual service mains, the main wires comes to the distribution meter board, that is energy meter board, and from the energy meter board, the actual lines goes to the switches, DPSC switches, that is double pole iron conduit switches. From these switches, the supply goes to the switches. From DPSC switches, these things goes to the switches, normally SPST switches or SPDT switches. So here we need to remember that this phase here, from this phase, this goes to the line switches, line conduits. From this line conduits, this goes to the phase. From this phase, this line goes to the this phase, that is switch. From DPST switch to the normal SPST switch. From here, the actual phase divides. That is for different distribution boards. That is to SMDB number 1, SMDB number 2, SMDB number 3. That is from this actual phase, this links goes to the normal distribution boards. And from neutral, the neutral lines goes to the other distribution boards of neutral. That is from phase of one distribution board goes to the other phase of distribution board, and from neutral of this distribution board goes to the neutral of other distribution board. And here also some same phase of distribution board goes to the different distribution boards and also to the other distribution board. We need to divide the circuits based upon our ratings. That part I will discuss in the later slides. So just you people need to remember that now the phases should be always connected to the phases, and neutral also always directly connected to the neutrals. From here, these neutrals goes to the different subcircuits, lamps, and phases should be connected from the switchboard phase. This is about the actual distribution diagram of our normal home appliances. And here the actual distribution of energy in a building. As per our Indian standards, maximum number of points of lights, fans, and other 5 amp sockets outlets should be connected to a maximum number of 10. That is, each circuit should be of contain number of 10 points. If it achieves more than 10 points, then we need to make another sub-circuit. So like that. And one more thing is the maximum amount of load for one sub-circuit should be not more than 800 watts. For example, if I am going to connect our home appliances, that is incandescent bulbs, fans, and sockets. These are comes under lighting circuits, and other geysers and ACs and kitchen appliances, bathroom appliances comes under power installations. That we need to discuss in other. That we need to divide into other part. But for lighting circuits, we need to consider 800 watts, and it should not cross 800 watts, and it should not be more than 10 points. 10 points. So like that, we need to make a sub-circuits. And number of circuits and sub-circuits are decided as per the number of points and loads that connected to the supply system. As I told, the sub-circuits and the circuits are based on divided into number of points that are connected to the actual line. Based upon it should not cross more than 10 points, and it should not be more than 800 watts. So in this distribution system, which is most commonly adopted for distribution of electrical energy in a building, this actual block diagram, actual typical diagram what I have given below, it's a system which is most commonly adopted in our distribution electrical energy, and fuses of various circuits are grouped together in a distribution board. That is, you people can observe here that the distribution board which I have shown in here is connected through the fuses, and fuses should be always connected with the phase and followed by the switches, and the neutral wire should be followed to the connected to the lamps and fans which is looped there, and it should not be linked to the switches. The actual connection to the switch comes from the lamps and fans. So the two copper strips. First thing is a fuse board, and the next one is the copper strips. The two copper strips are normally used as a bus bars, and these should normally connect to the distribution board with the hard wood or metal case. And a fuse is inserted in the positive or phase pole, and each circuit, so that each circuit is connected up through its own particular fuse. The number of circuits and sub-circuits are decided as per the number of points. As I told, the sub-circuits and circuits should be decided based upon the number of points that are connected to the line and the maximum amount of load that it is having. So for our fluorescent lamps, it should be of normal fluorescent lamp is considered as a 50 watts, and incandescent lamps, fans and socket outlets are considered as 60 watts, and other power sockets outlets considered as 1000 watts. So like that, we need to divide the whole electrical system. So in this diagram, as I told already, this is a phase lines. This is a phase socket, switch, phase connection in the switch. This is a phase connection in the switch. This is the neutral connection in the switch. From the phase circuit, all the lines are connected through the phase lines, and here the neutral links are connected to the circuit 1, circuit 2, circuit 3, circuit 4. Like that, all the home appliances should be having a phase and neutral. So the phase should be connected to the fuse and as well as switch. The neutral link should be looped in such a way that all the neutral links should be connected to fans, lamps, sockets. And these are different types of wiring. This is a cleat wiring. First diagram shows the cleat wiring, and this second diagram shows the casing caping in a wooden wiring. So normally in a cleat wiring, we can it's nowadays it's vanished already. Normally cleat wiring we observed in British era or in our village old village homes, where tunnel like switches are normally we can observe here in cleat type wiring, and in a wooden casing caping. So the casing caping is nothing but we need to carry out our what we can say the lines, conductors from the distribution board to our home appliances. So for that purpose we need casing and caping. In casing means it holds our wires. Caping means which closes the electrical wires. So different types of casing caping are there. The below figure shows the wooden. If it is used by PVC, then it is a PVC casing and caping. See here. Here we can see here PVC casing and caping. Here, as I already told, casing which holds our electrical wires, caping which is closes, and it makes sure that our electrical wires are not visible from the outside. For the neatness purpose and for as a disciplined purpose, we use casing and caping. Normally, this kind of PVC casing and caping we can observe in day-to-day our life. Normally, we can normally we can see in our computer labs. So where the continuous casing caping pipes are laid, if we need to add some more what we can say computers into our lab, so we can just remove the capings and lay the wirings through the casing and connect to our computers. So for that purpose, PVC casing caping are normally very useful in our labs. Conduit wiring. So in conduit wiring, this is a system the best for domestic and commercial installations. So normally conduit wirings are used in domestic and day-to-day life, and it provides proper protection to the installation against fire hazards and shock, mechanical damage and dampness. That is, these kind of conduit wiring is provided for proper protection purpose and also for against the fire hazards. And the cable used in the system is either VIR or PVC insulated. In this system, the wiring steel tubes known as conduits are installed on the surface of walls, by which the sadness or pipe hooks are buried under the plastic, and VIR or PVC cables are drawn from out afterwards. That is, if so conduit wires can be of galvanized iron steels or normally PVC pipes. So in order to facilitate drawing of wires, number of inspections fittings are provided along its length, and the conduit size based whatever the size which normally the conduit wires are holding. This conduit size is started in terms of outer diameter, and the smallest size is 12 mm and the biggest size is 16 mm. PVC conduit pipes are also available now and are increasingly employed. That is, in previous eras we were using galvanized iron steels. but now it is already almost vanished. Now instead of that, we are using PVC pipes. The conduit used for this purpose is of two types. That is a light gauze and heavy gauze. Light gauze is normally called as split type, and heavy gauze is called as a screwed type. So length is used for cheap work, and cheap and normally cheap and best, like that. For cheap and easiness, they are using different conduit wires, conduit tubes. So there are two types of, as I told, two types of conduit wiring, that is surface conduit wiring and concealed conduit wiring. Here you can see that surface conduit wiring, this is and this. Normally in our day-to-day life, we can see this surface conduit wiring in the outside of our home. In a village side, what they do, they get the supply from the service mains, and through the conduit tubes and conduit wires, they are passing our electrical wires through the surface of our walls. These also is a different junction box, and these are conduit tubes or conduit wires. Through that, the electrical wires are passing to the devices. In concealed conduit wiring, that is in modern era, that is in today's generation, we are using like this type of conduit wiring. That is, after plastering of our wall, after constructing a wall, they are going to break the walls with the desired amount of conduit sizes. Based upon the conduit sizes, they break the walls and place the conduit tubes. After that, they make a plastering of walls. So we can see, observe here, this is a socket outlet. Only the socket outlet is visible. That is, in our day-to-day life, we can't see the conduit wires in outside of our walls. These are inbuilt in, that is concealed. These are within the walls. So this looks good actually, and for beautiful of our appliances and beautiful of our home surroundings, it's a very good type of conduit wiring. So that if like this, there are some advantages and disadvantages of us also for these types of conduit types in concept surface. If we go for surface conduit types, it's not looks good, and it's looks odd for visible purpose. But if you go for concealed type wiring, it's buried inside the wall. But the disadvantage is, if something broken inside, or some while constructing a wall, while constructing the plastering, if something blocked inside the conduit, it's very difficult to remove those blockages. So care should be taken while constructing concealed type of wiring. Okay, this is a normally chart. This chart shows the cross-sectional area, cross-sectional area of one small conduit size, and this is a number and diameter of wires. This is how many numbers of wires can pass through that conduit. The size of this is a cross-sectional area, and this is the size. If 16, 20, 25, 32, 40, 50. These are the different number of conduit sizes based upon the requirement, based upon our requirement of size of cables, and based upon the conduit size, we need to decide the size of conduit. The area, if I am going to, for example, if I am going to 1 square mm conduit wire tube, then I need to pass 1 by 1.2112 mm of copper wire. So normal different types of wirings are there, conductors. We can go for copper wirings or for aluminum wires. So based upon the load, we need to decide which type of which size of wire we need to select. If for our home, for our appliances, it is consuming 1 ampere or 1 ampere of current, then 1 by 1.12 mm length of wire we need to connect through the 16 size. There is a number of cables of maximum 5 cables can pass through the 16 number conduit. So like that, we need to decide the size of the wire, amount of load connected, and the number of wires that we need to pass through the conduits, and the cross-sectional area. So by studying this chart, we can decide the strength. So as I told, what are the different advantages of conduit type of wiring? That is, it's a good protection and against fire. If I am going for what concealed type of wiring, concealed type of conduit wiring, then it's a good protection against a fire. That is, if some fire hazards happen inside our home, these wires are not directly exposed to the fire because it's concealed inside the wall. So, and provides protection against moisture in the atmosphere, and damages of cables can be replaced easily. That is, if we go for conduit type of wiring, if some damages are occurred inside our cable, we can detect it and we can easily remove it and replace it with the new wires. And good appearance, as I told, it's for good appearance purpose, and life is very long. That is, if I am go for considered type of wiring, then the amount of materials and quality of materials which we are selecting should be of good proper quality materials, so that the life will be automatically good long. So if we choose for good quality materials, then obviously it's of high cost. So that's the disadvantage. And if there any burns inside a conduit, and causes insulation of cables to be damaged. So inside the conduit, if some due to over voltage or due to fault, that's over voltage or current faults, if something happens to our insulation, and it automatically burns, the insulation will be burns. So because of that, as there will be some hazardous may happens inside the cable. That's a disadvantage of thing. And the next thing is, what are the most desirabilities of our wirings? First thing is the initial cost. It should be of economical. The wiring which we are going to select, it should be of economical purpose. That's the initial cost should be minimum. And durability. That's how long the wire should stays. It is must be able to withstand wear and tear due to weather. So desirabilities of wiring means what are the qualities that our wiring should have. This is the initial cost, and it should be have an economic purpose. That is, if you are a good estimator and you need to make sure that you have to minimize the cost and make sure that you have to maintain the life of that purpose, life of that actual work. So like that, you need to decide the things. The cost is over the durability. Now, that is the quality of wire that you are choosing should be able to withstand the for longer duration, and it should be not exposed to the wear and tears. And safety from fire, it should be free from a risk of fire as far as possible. That is, if it should not be directly exposed to the fire suddenly. Like that, wire you need to select. The mechanical protection, it must provide good mechanical protection to the cables. The strength of the wire, and the casing caping and the conduit wiring, what these by making sure of all these things, you need to protect your cable. That's a which should be able to withstand any mechanical what we can say mechanical loads or mechanical appliances. So the you need to protect your cable from any mechanical devices. The permanency, the wiring must not be affected by the action of weather, fumes and chemical, etc. The appearance, how appearance looks, it's an architectural point of view. In an architectural point of view, our home and our not only home and our industry, it should look neatly. Then appearance wise, it should be disciplined. Like that, you need to make sure of your wirings. Accessibility, it should be very easily accessible. And extended to or repair with the wiring. If you need to make any changes in the wiring, or you need to make a replacement of wiring, so like that, it should be very accessible. Life, the next thing is life. In the system adopted should have good life. Whatever the system or whatever the wirings you are chosen, it should be of able to for a good life. That's it. So for long durations. The maintenance cost, always it's obviously that should be low. If you are a good estimator, you need to minimize the cost. For that purpose, you have to make sure of cheap and best materials. That is the initial cost should be low, and you have to make sure of good quality work, and also able to withstand for longer duration, and also it should be of low cost maintenance cost. In the next session, we can go for wires and cables. here in this section, we can study the different types of cables, different types of wires, and what is meant by wire and what is meant by cables. So in single wire may be a bare or covered with insulation is known as wire. That is, if a wire, normally a wire is a conductor which may be a bare or insulated. Normally the different n number of wires is a one conductor and one more conductor, single core or multi-core conductors are wounded together. This is called, if these wires are insulated, and normally these kind of wires are called cables. That is, several wires wounded with the insulation is called cable, and a single wire which is bare. Some part of researchers, some stalwarts in our field say that single wire may be bare or covered with insulation is called as wire, and several wires standed together called as cable. But in some other literatures, in some other books, they are saying that in straight away a wire which is bare, that is without insulation, is called a wire, and a conductor with insulation is called conductor material used in cables. So normally what are the different types of materials we are using in conductors are copper and aluminum. So copper, in copper always it's a good conducting material. When compared to copper and aluminum, silver and gold are very much conducting materials. But due to the cost of that, we can't use the silver and gold. So instead of that, we are using copper and aluminum. One thing you people can remember that gold is a very good conducting material, but we can't use gold for our wiring purposes. But you can see a small amount of gold as a conducting materials in our PCBs, that is printed circuit boards. In computer printed circuit boards or in our TV, LED TV printed circuit boards or our mobile printed circuit boards. We can see the small amount of gold used as a conducting material. But for our wiring purpose, wiring system, we use only copper and aluminum. That's straight away. So silver is the best conductor, silver and gold are the best conductor, but due to higher cost, it's a rarely used. Not rarely used. Only in some electronic goods they use silver and gold, but in our day-to-day wiring system, for home wiring system, we don't use anywhere. This gives how the conductivity and different devices, different appliances are there. The rubber is a very good insulator, but not a conductor. This arrow mark shows different types of things and insulating, semiconducting, and conducting natures. So rubber is a good insulator. Glass, wood, dry air, these are comes under good insulators. But silicon and germanium are sometimes acts as insulator, sometimes acts as a conductors. So these are semiconductor devices, silicon and germanium. And next comes under conducting parts, that is water. Pure water is not a conductor, it's a insulator, but salted impure water is a good conductor. Carbon, mercury, iron, aluminum, copper, and silver. Next comes under gold. So like that, the conductivity, insulator, and semiconductor varies. Oh, here we can see that different types of cables. So the cables are classified based on conductors, based on number of voltage gratings, based on conductors used, and based on insulation. So as I already told, cable means it's a wire with insulation. So wire wounded with the insulation is called cable. Based upon the insulation levels, we can decide the cables. On the basis of conductors, first if I consider on the basis of conductors, it may be a single core cable or multi-core cable. That is, single core means one single strand of wire, single strand of copper or single strand of aluminum. This is a single core cable. If I go for multi-core cable, that is the same. Single strand is wounded one above the other and made it as a multi-core cable. And the next is on the basis of number of voltage grading. That is,
If I am using for 250 or 440 volts cables or 650 or 110 volt cables. That is, this is a 250 or 440 volt cables means of medium voltage and low voltage levels, and 650 or 110 volt cables are for high voltage and extra high voltage cables. So based upon the voltage, we can divide the cables. Then on the basis of conductors used, that is, as I already told, if I am using copper, then copper conductor cables, and if I am using aluminum conductor cables. These are based on types of conducting materials we are using. And the next thing is based on insulation. So based on insulation, VIR insulated cables, TRS or CTS cables, lead sheathed cables, PVC cables, weatherproof cables, flexible cord cables, and XLPE cables. What are they? What are these things? VIR insulated cables. So here you can see here 7-stranded copper conductor. As I already told, single core or multi-stranded cores. This is a multi-stranded core. Single cables are wounded one above the other, and later these bare conductors are covered with the insulation. These are copper stranded cables, multi-core cables. This is a single core cable, and these are again multi-core cable of small size. And this is a multi-core with each core is insulated. Like this, you can see here 2-core cables, 3-core cables, 4-core cables. Here, these are the processing. Here, based on insulations, we are decided VIR insulated cables, CTR, TCR, or PVC, lead sheathed, like that. So we can see the one by one. VIR, vulcanized Indian rubber insulated cables. So these are this insulation are with rubbers. These were used. These are normally using in our day-to-day life. In Indian vulcanized rubber, they are normally using rubber as a insulation, as I have shown in arrow mark slide, that rubber is a good insulator. So they are using rubber as an insulator here. So this is a single strand because core is a single, and here they are using rubber as an insulator for single core cable. And here it's a 7-stranded 1, 2, 3, 4, 5, 6, 7 7-stranded single core cable, VIR cable. These are made as a single. So this again rubber is used here. So VIR cables are available in 240 or 415 volts as well as 650 for 110 volts. That is, if I am using it for normal voltage, that is minimum normal voltage levels, this is of 240 or 415 volts, and for higher voltage levels, this is for 650 or 110 volts. It consists of either tined cable, tined copper conductor covered with the layer of vulcanized Indian rubber insulation. So over the rubber insulation, cotton tape sheathed covering is provided with moisture resistant, because if some moisture content is there, they need to remove that moisture. For that purpose, they normally use cotton to remove moisture, and wax or some other insulating materials for making the cables moisture proof. The copper conductor is tined to provide protection against the corrosion, and due to the presence of sulfur, zinc oxide, and other minerals ingredients in the VIR, they normally prefer, in order to what we can say, these vulcanized Indian rubbers are coated with some cotton to absorb the moisture contents, and also to protect our coppers from corrosions. That's why they use cotton on the vulcanized Indian rubber. and it's a same. As I told, this is a cotton braiding is done over the insulation to protect conductor against the moisture. And finally, the wire is varnished with the wax for cleanliness. They rub the wires, cables through the wax. These are not used since for better quality wires are available for they use and apply color, and after they have to clean it the wax. For this requires some higher cost. For that purpose, they normally don't prefer like they using PC, normally PVC. And this is a next again one more thing that is like that VIR. This is a TRS, tougher rubber sheet or CTS cab type sheathed cables. This thing is just like this is a single conductor is again insulated with the inner insulation, and again this is a single core 7-strand TS cable. These stands, 7 stands of conductors are wound one above the other and made it as a single core. Same like that, again inner insulation and outer sheath with a tough rubber sheet. This is a twin core, that is each strands are made into another number of strands are made into another core. So one core with the multi-strand like this. This is a 7-strand course, right? Like that, 7 strands core are made it into one single core. Like that, we are made it as a 2 cores. Here it is a 3 cores, and each core is insulated with the insulated cab type sheeted or tough rubber sheet. So this type of wire is a modification. Like that in vulcanized Indian rubber it's a modified, and it consists of the ordinary rubber coated conductors with additional sheet of tough rubber. And this layer provides a better protection against moisture and wear and tear. Wear and tear means if it may breaks while handling or while maintaining. So for that purpose, it should be of wear and tear. And it also provides the extra insulation, because here these things are inner insulation and outer insulation. Inner insulation, outer insulation. These are with inner insulation and outer insulation. So for if there are 2 types of insulation there, these provides better extra insulation. This is an advantage compared to VIR. These wires are generally available in a single conductor, 2 conductors, 3 conductors. The next wire is lead sheathed cables. Here we in previous slides we observed that rubber is used as a insulation. Here lead sheet is using as a protection. Lead sheet is using at the outer surface. Inner surfaces, inner cables are normally insulated with the VIR and CAB or TRS, whatever, but the outer sheet are made up with the lead sheet. Like these cables we can observe in underground cables. Underground cables, they use lead sheet for outer surface, because after digging the ground and we need to bury it on using cables under the ground, so there will be a high mechanical loads, high mechanical strengths are applied on the particular cables. We need to protect these cables from the external mechanical loads. For that purpose, we use lead sheets. Ordinary wires can be used only at dry places, but for damp places, these wires are covered with continuous lead sheets. The layer of lead covering is very thin, like 0.12 centimeter thick. That is the lead, whatever amount of lead we use for outer surfaces, these are very small layers, and provides here, as I told, mechanical protections to the wires. We mainly use these kind of lead sheathed cables are mainly used for underground cables, and lead sheath is used for mechanical protection. Next thing is the PVC insulated cables, polyvinyl chloride. So day-to-day life, in our day-to-day home appliances and everywhere, we use PVC. So this PVC is easily available and cheap. And also provides a better mechanical strength. For that purpose, we use PVC insulated cables. Since PVC is harder than rubber and it does not protection against mechanical moisture contents, PVC insulation is preferred over VIR. Why PVC is preferred over vulcanized Indian rubber cables?
it has a better insulating qualities. As I told, rubber is least insulated. Other than that, PVC is the most insulated. So PVC is a harder and it's a good insulator compared to rubber. So it's obviously better insulating qualities. PVC has better insulating qualities. It's also provides better flexibility. It has no chemical effect on wires. Rubbers may act as the time passes. Rubber acts with the insulation. It acts with the cable conducting materials. But these PVCs don't have any chemical effects with the wires. The thin layer itself provides desired level of insulation, and diameter will be less when compared to rubber. The PVC what we are using here, which of diameter will be less and accommodated inside the conduit of given size in comparison with the VIR wires. And the PVC wires are most widely used for internal wiring purpose. This is the main thing. Internal wiring purposes, that is inside the conduits, inside the concealed type of conduits, these PVC wires are used. The one more type of wire is a weatherproof wires. That is which these kind of wires don't act with our atmospheric conditions, whether it may be summer or rain. These don't act with our atmospheric conditions. That is, first thing we can see that these are 1, 2, 3. These are the conductors. These conductors are insulated with the vulcanized Indian rubbers, and again these VIR insulation is covered with the insulation of one more VIR. This there is no strict rules that this should be of VIR only. Maybe PVC also, or some lead sheath also. And after this is a weatherproof insulation. Normally what happens, these weatherproof insulations are lead or fibrous materials, sand tapes, like the different insulating materials comes. These are laid one above the other. The stepwise step. One cable, after that one insulation, other after that one more insulation, after that the last thing is the lead insulation, like that. Normally these type of cables again used in our UZ cables. And these types of wires used for outdoors. That's why weatherproof wires we are using in outdoors. That's why it is a weatherproof wires. For in order to make use it in outdoor system, we made the cables into weatherproof wires. This service connection from overhead lines to buildings. It is service mains. What we are using, these are normally preferred weatherproof wires. In this type of wires, the conductor is not tined and conductor is covered with the 3 braids of fibrous yarn and saturated with the waterproof compound. I had already told the core is covered with the insulation and the one more insulation here. After this, fibrous materials or Hassan tape insulating materials will be used for moisture absorption. That is for weatherproof and also to give mechanical strength to our wire. That's why these are different types of structures are constructed one above the other. It's a kind of one more thing, weatherproof wires. The flexible wires. So name itself indicates these are flexibles. These wires consist of number of strands instead of single conductor. So instead of only single conductor, if a single conductor is there, it is not easily flexible. Normally wires are multi-stranded with a small gauge. And conductor is insulated with the PVC material. Yes, PVC or vulcanized Indian rubbers are using. When compared to rubber, PVC is a good insulator. That's why PVC is using as a insulating materials in normally every cables. And these wires are very useful for household portable appliances where flexibility of wires is more important. Flexibility. If we can't use single standard cables for inside our home because it's not flexible. We have there are the corners in our homes and we need to make straight left, right, and we need to make interconnections. For that purpose, we use flexible ways. That's of multi-standard cores. And the typical specifications. What are the main specifications of these flexible wires are 55 bar 0.01 mm. That is 55 55 bar 0.01 mm means 55 strands of 0.1 mm diameter wires. Here it's a stick here.
55 bar 0.1 mm. 55 strands of wire with
0.1 diameter of wires. The maximum current of 6 amp used for our household purposes. That is, we need to, before what we can say, before going to wiring, we have to make sure that it should able to withstand the maximum current and minimum current, under current and maximum over current also. Normally what happens, it's what the home, now home, by calculating all the loads and with the reference to the voltage, normally the current not reaches more than 6 amperes. So 6 ampere current with the maximum 6 ampere current it can withstand. Like that, we need to select our gauge of wires and strength of wires. The next thing is XLP cables. This is also a different type of cable built by polymers, and by using of different types of polymers, the cables are constructed. And
polymers are such substances consisting of long macromolecules built up of small molecules or group of molecules as repeated units. That is, different types of macromolecules and small molecules are placing in different units, and by mixing of all these units, they are using as a polymer.
The polymers are divided into homopolymers, copolymers. That is just like as normal cables. Normally they use in UZ cables. UZ cables, XLPE cables, cross-linked polyethylene cables. These are called cross-linked polyethylene cables. XLPE means by using these kind of polymers. So normally these type of cables are preferred in chemical industries. So which should not act with the other chemical things. Chemical industries are normal, and what you can say, paint industries. So they use like this of XLP cables, which not easily acts with the other chemicals. So like that industries, they use XLP cables. Multi-standard cables. What are the main advantages with respect to the single solid conductors? The multi-standard cables are more flexible and durable.
How more flexible and durable? That is, in multi-standard,
it's not continuous. If the same thing happens single strand conductor, if there will be any one strand, and if that same strand, that is one single core, is broken, then there will be no supply of electricity. But in multi-strand cables, the one single strand is broken while wounding or while handling, it's not stops its conducting, but it's more flexible and durable. And the next thing is surface area is more as compared to the equivalent single solid conductor. So heat radiating capacity is more. What it means, surface area is more. And if I use same single strand conductors as multi-strand conductors, then the size, the space required will be of more, and same time the heat generation, the heat generated, that is, normally the cables generate heats when the same the rated capacity of current exceeds. If the rated capacity, the water which predetermined current rating is exceeded, then the losses will be in terms of heats. The heat is generated. This heat effect will be more in surface area. So the requirement of surface area and heat generation will be more in multi-standard cables. Then skin effect is better. What is meant by skin effect? That is, skin effect means the passing the whatever amount of current passes through the cables, in that cables, the current passing through the core at the center of the core is less compared to the outer surfaces. That is meant by skin effect. That is what is meant by skin effect. The current passing through in multi-strand conductors, the current passing through the multi-strand conductors, the amount of current passing at the outer surface is more compared to the inner center core. So this is called skin effect. In that skin effect, it is more in multi-strand cores. Then the number of strands in standard cables must be 3 size, 7 size, 19 size, 37 size, and 97 size. These are the number of strands we can use. The standard. We have to use 3 standard cable or 7 standard or 19 like that. We can't use 4 stand, 8 stand like that. The standard. Some Indian standards are there. The next thing is voltage gradient of cables. That is the cables should be selected based upon the different voltage grades. Specify the safe voltage. That is, we need to select our cables based upon the voltage ratings. The supply voltage is more, but the cable what we have chosen is of less standard, then it's a problem for our devices. That's why we have to make sure that the standards what we have chosen while selecting the lines of within the specific rates. That is, specify the safe voltage which the insulation of cables can withstand. The cables employed for domestic wires are graded of 650 bar 110 volts. And what are the main general specifications of cables are the size of the cable, giving number of strands used, and the diameter of each strand. These are the some strands, the specifications that each and every cable should follow. That is the size of cable, giving number of strands used, and the diameter of each strand. These are the, for example, 19 bar 2.24, 7 bar 1.70, 7 bar 2.24, 7 bar 2.5, like that. The type of conductor, that is the specific of any cable, specifications of any cable, that is how much size we are using and what type of conductor we are using. Normally aluminum and copper is the type of conductor using. The number of cores, that is single core cable or 3 core cable or a twin core cable or multi core cable. That is, it should have some specification like this also. Voltage grade, whether these voltages, for normal voltage levels, it's 240, 230 plus or minus 10% of tolerance, 240 for single phase, and 420, 415, 430, 440 for 3-phase 4-wire systems. So these cables should have this limit for 3-phase 440, single phase 240 volts. For this, for normal voltage levels. If I am going to consider for high voltage and extra high voltage condition, you should have follow the 650 or 110 volt grades. And type of cable, that is these things, different types of cables still till now we have studied, no? So which type of cable we need to select? Like that, we need to select the specifications of cables. I think this enough for today. The remaining things I will continue in the next class. Now it's your turn. Unmute yourself and ask, is there any queries are there? Is it okay today? Hello?